Hello, everybody. We're just going to wait 1 or 2 minutes to let the other attendees join us. There's a few more coming through, and then we'll be right back with you. Okay, I think we can begin. Hello, everybody, and welcome to the Research Data Alliance's second webinar today on data description. My name is Bridget Walker. I work with the Secretariat at RDA Global, and I'll be moderating today's webinar together with my colleague Ryan O'Connor, a Research Data Specialist from the Digital Curation Centre in Edinburgh. Thank you very much for joining us, all of you. We have around 45 attending today, and we're very happy to be able to share with you an overview of the adoption projects implemented and ongoing at RDA, and to give you the opportunity to discuss these projects with our speakers. Before I introduce our 3 speakers for today, I would just like to quickly go over a few technical details. This webinar is in listen-only mode, so you can hear me and the speakers, but we cannot hear you. If you have any questions for the speakers, you will have the opportunity at the end of each presentation. You can either write your questions in the question box, which is at the bottom of the GoToWebinar interface panel, or you can put your hand up and we will unmute you. If we are unable to answer all the questions that come in, we will definitely follow up with you offline, so please don't worry. And please note the webinar is being recorded and the link to it will be posted within the next day or so. So the Global Adoption Week has been organised around 5 different research data life cycles, with 2 sessions for each life cycle, which highlight examples of how the recommendations have had an impact on their adopters. Today's presentations are focused around the theme of data description. And today's speakers are Anne Thessen, an Assistant Professor of Senior Research at Oregon State University. She's also co-chair of the RDA TDWG Attribution Metadata Working Group. And we have Thomas Jejkal, a data manager at the Karlsruhe Institute of Technology in Germany and co-chair of the Research Data Repository Interoperability Working Group. Finally, we have Dimitar Vassilev, the bioinformatics group leader at Sofia University, who will tell us about his adoption of the recommendations from the Wheat Data Interoperability Working Group. Before I pass you over to Anne, our first speaker, we'd like to see who we have in our audience and why you've joined our session. So if I could ask you to go to Slido and enter this code, W343. And the first question we have here is, what is your primary role? So if you could indicate from the choice here, researcher, research support staff, project manager, IT specialist. Okay, so IT specialists is the majority so far. And we have quite a wide mix of people in our audience. Okay, if I move on to question 2. So we'd like to know what your primary domain is. Okay, so natural scientists we have at the top here, but we have members right across here, which is great to see. Okay, moving on to our last question. We would like to have a question from you. If you have a question or an issue that's related to data description and the RDA outputs that you would like to learn more about today, is there a particular question that you have on your mind that you'd like to hopefully be answered by one of our 3 speakers today? Nobody has any burning questions. Here we go. Okay, so RDA activities in general, elements of data description most useful. Question there about which tool can be used, are the challenges to adoption, and making things less painful for researchers, and describing their data. Okay, well, thanks very much for that feedback. And now it's time to hand over to our first speaker, to Anne. Over to you. Brian, if you could change the presenter for me.
Yeah, so Anne, you should be presenter now. Should be able to share your screen.
Yeah, it's coming up.
Oh, there I am. I was trying to tell you that I was muted.
Oh, sorry.
Okay, excellent. All right. Hello, everyone. Thank you for coming to my talk. My name is Anne Thessen, and I'm going to speak to you today about attribution metadata standards for collections. So these are research collections for containing physical objects or digital objects. And these recommendations were developed within the context of an RDA working group, but this working group is also endorsed by a biodiversity standards body called TDWG, and I'll talk more about exactly what that means in a moment. But what I'm about to present represents the work of several people, including my co-authors who are listed here. So the recommendations of this working group were designed to address the problem that curating and maintaining research collections is very important, but current incentives do not support this work. Creating a metadata standard for attributing this work will help people and institutions get credit, thus hopefully changing that incentive structure. So the recommendations that I'm about to discuss were developed within an RDA working group. And as we all know, RDA working groups have 18 months to formulate their recommendations. And this group has been through that 18 months, and the recommendations were submitted and published. But this is really the end of the RDA process is the beginning of the TDWG process. And so those RDA recommendations have been used to justify an extension to a biodiversity standard called Darwin Core. And you can see that work here at this GitHub link. And there is also a companion interest group within TDWG to look at ways to identify people, which is a very important component to being able to implement this recommendation. And I just want to say that this working group came out of a biodiversity interest group. And so while we've had a focus on biodiversity and natural history, the natural history discipline, we by no means wanted to create a recommendation that was only useful to that particular domain. And so these recommendations are only the beginning of the process. And this is the recommendation that I've been talking about. It consists of 3 parts: an entity, which is the specimen or the data object, and that is generated by some activity, which is what the person is doing, and is associated with some agent. So the agent is the person or the institution that engages in a curation activity and that generates some sort of new object or transformed object or metadata about an object. So those three parts are the only required parts of this recommendation. There are two optional parts, which is to ascribe a role to the agent, and also you can add a start and an end time and a reason to the activity, but that is not required. Now, this model is based on the provenance ontology, which is a W3C standard. Now, not every discipline has a standard, and some disciplines already do have a standard. And so what we're thinking is that this can provide a meta model to integrate data across disciplines. Now, most disciplines don't use the provenance ontology or any real standard at all for attributing curation or collections activities. So what we're hoping is that this can fill in the gaps for disciplines that have no standard or disciplines that do have a standard by mapping that standard to this model. And then you can bridge and integrate data across disciplines. So we divide our adopters into two tiers. Tier 1 is providers of attribution metadata. So these are organizations or pieces of software that gather this data. Usually a museum will use some piece of software to manage their collections, to keep track of who is doing what with the different specimens. So these institutions include things like Arctos, iDigBio, Bloodhound, Taxon Works, GBIF, and Disco. Our tier 2 adopters are consumers and presenters of this attribution metadata, like Orchid, Impact Story, or Altmetric. And so the idea is that the people working with the collections will provide that data to one of the tier 1 adopters, and then the tier 1 adopters would provide the data to the tier 2 adopters for consumption. And so this recommendation is a way to exchange attribution metadata between tier 1 and tier 2 adopters. And so far we've engaged in 2 pilot projects involving Orchid, Bloodhound, and Data Futures. And for those of you who are not familiar with Bloodhound, Bloodhound is a project where people can go in and claim their specimens, or say, you know, this person collected this specimen, and it aggregates that data and presents a unified picture of someone's collections history. So this is an example of what the Orchid pilot project looked like. This is an Orchid profile for one of our co-authors, David Peter Shorthouse. And here are 2 work objects in his Orchid profile that include natural history specimens collected or identified. And so the way that we got this to flow is by putting the information in a spreadsheet and then putting that spreadsheet into Zenodo. So this got his specimens on his Orchid profile, and it's been assigned a DOI, and it can be versioned as things are updated, which is all very fine and good. But the problem is that Zenodo metadata does not accommodate actions in collections. So we do lose a lot of the metadata and the nuance. And the second pilot directly addressed one of the huge obvious problems that we have with implementing a standard such as this. And I'll talk about that in just a moment. But there are 2 implementation elephants in the room here. One is that specimen identifiers are notoriously poor. And these images show examples of just the kind of identifiers that you might see in a natural history collection. And they can vary from numbers, catalog numbers like this, all the way to barcodes. And sometimes you just have jars with lots of organisms in it that don't really have any identifiers on them at all. So it is very heterogeneous and very messy. But the way that we were going to try and address this problem was by looking at the graph of identifiers on a specimen record. So let's say that you have 2 specimen records from 2 different sources. How do you know if these two different specimen records are referring to the same specimen or different specimens. And we're exploring ways to do this by looking at the overlap of the identifier graph attached to each of those specimen records. So for example, if you have two specimen records from two different sources, you can look at the graph, and we see here that the graph overlaps perfectly with three different records. So there's a match for three identifiers in the identifier graph of these two different specimens, and there's no contradictions. So we can conclude that these two different specimen records are about the same specimen. So the second implementation elephant is the fact that some people are very prolific, and so we don't want Orchid profiles that show thousands or even tens of thousands of specimen records or curation records. That's just too much. So our second pilot project worked with the Data Futures Partnership to explore using their archive lists and archive collections to find a way to package collections or curation activities into some sort of digestible chunk to display on an Orchid profile. And that it turned out that that method wasn't quite going to work for us. So we're still exploring ways to make that happen. And the last activity that I'm going to describe, but certainly not the least important, is the different terminology extensions that have needed to happen in order to implement these recommendations. And first of all, as a result of our Orchid and Data Futures pilots, Orchid is adding a physical object work type to their terminology, or they have already added it. So you can now have a physical object work type in your Orchid profile. We've also added terms to the contributor role ontology, which is a product of the CD2H, National Center for Data to Health. And we've added terms to Vivo. So Vivo is the ontology of activities that we would want to attribute, whereas the contributor role ontology are all the roles that we would want to use to assign to the different agents. And we are always collecting new terms. So if you have an activity or a role that you would like added to these ontologies, please go to that link and let us know. And so that's what we've been up to with our recommendations. And with that, I can take questions. Let's see, it looks like I am supposed to be able to call on people here.
Yeah, if anybody would like to write a question for Anne, they can put it into the question box, or please raise your hand in the panel and I will unmute you. Okay, we have a question here coming from David Roman, and his question is, where is Vivo available?
So Vivo has a GitHub repository. So if you want to just view the ontology, there are a couple of GitHub links that I can show you. If you have questions or want to be able to implement Vivo in your own system, then I can direct you to their Slack channel, which is where I've been learning about Vivo and getting help adding my terms. So that depends, and we can I can work with the organizers to get you those links after the talk is over.
Okay, we have another question here from Nick Duty, and his question is, why is it a problem to have lots of specimens attributed to one person?
The only problem is viewing it on an Orchid profile. So it's more of a user interface visualization problem. It's not really a technical problem, if that makes any sense.
Okay, next question's coming from Catherine Rousset. Her question is, can we have an example of the graph with the role?
An example of the graph with the role. So let's see if I can figure out how to go back. Yes, okay, so this is the graph, and with the role, so it would basically just look like this without the word optional there. So you would have your entity, activity, and agent, and then the agent is associated with an activity, and you would have a blank node here, and that blank node is only there if you want to add the role. So this is a blank association node, and you would just add the role onto that. So it would be this agent has this association, and in the context of this association, they had the role of curator or collector or something from the contributor role ontology. And I will also add that the roles in credit are also linked to the contributor role ontology.
Okay, thank you, Anne. We have 2 more questions, which hopefully we can answer before we move on to our next speaker. Okay, next question is from Maggie Hellstrom, and she would like to say, she says, can your recommendation also be directly applied on collections of digital objects, such as those covered by the RDA Research Data Collections Working Group?
We intended for that to be the case, and we have developed this around several use cases for digital research collections and digital data objects. So my tentative answer is yes, but we have not yet been able to work with a partner who wanted to apply this to a digital research collection. So if you would like to work on that, that would be great if you could reach out. So I anticipate that we will find the snags in the system once someone sits down to actually try to do it. But the intent is there, yes.
We have a follow-on question from Nick, who asked about specimens attributed to being just one person, and he's asking now if they can't they just be collected into an expandable box?
Yes, that's what we were exploring with data futures and with Zenodo. We're going to have to work with Zenodo, if possible, to see if they can capture the collection-specific metadata. Then if they can, then that will work. But trying to do the expandable box in using the data futures technology was not working. So, or we have to work directly with Orchid to try to get them to sort of change how they present work objects on the web page. I mean, in theory, the answer is yes. It's just the nitty-gritty of making it happen.
Okay, and the last question, I hope we can just quickly squeeze in, from Suzanne Pilsk. Any ontology changes to Wikidata, P terms?
Wikidata what terms?
P terms, P for potato.
P terms. I'm not sure. I'm not familiar with what P terms are. In
okay, well, perhaps we can ask Suzanne if she could follow up with that, and then I can pass that on to you, Anne, after the webinar, because we need to move on to our next speaker, I think. Thanks very much, Anne.
Okay.
We're going to move on now to Thomas for our second speaker.
Okay, do you see my presentation?
Yes, we do.
Yep.
I think so.
Yep.
Okay, so hi everybody. I will present the final recommendations of the Research Data Repository Interoperability Working Group. I was co-chairing this group together with David Wilcox from DuraSpace, and we wrapped up about 2 years ago. And our main motivation with which we started was the challenge of the exchange of digital content between repository platforms. So this, I assume everybody knows, can be challenging. This is because of different data models which might be in different repositories, different metadata which is stored in there, different semantics, or even interfaces to access the particular repository platform. In the current state of the art, there are of course some standard mechanisms to obtain data from repositories or to deposit data in there. They are well adopted, but they are quite limited. So probably everybody of you knows Dublin Core as a standard metadata schema, OAI PMH, and also the sort protocol for depositing data. Upcoming approaches like a linked data platform or resource sync or OAI or E are still supported by a comparably small number of platforms. So what we did is we created a matrix of lots of repository platforms. We compared what is in there and what is planned to be integrated. And these upcoming approaches will only in some cases be targeted for the future. We also defined some use cases we want to aim at. So these are the migration, the replication, and the cross-domain sharing of content. Examples are the migration between the same platform. So if the version of a platform changes, that you have to migrate the content from the one to the other version, or the migration between different platforms, or scientists who want to share their data with other scientists from other domains. We collected all these use cases and current status of different platforms, as well as this capability matrix in the so-called Primer document after about half year of the working group runtime, and you can find it at this DOI. Based on this document, we discussed on what to implement and how to implement something like a recommendation for this specific case. We found a consensus on a Bagot-based approach. So Bagot is basically a packaging format for arbitrary types of data and metadata and things like that. What we added on top of it is that we recommend a location where to put metadata, and also a naming scheme for these metadata documents contained in a bag. We also recommend to include basic metadata in following DataSite 4 schema. This was because many of the platforms we looked at were already having DataSite support or were planning to implement DataSite support. So this was somehow smallest common denominator of all the platforms we checked. And finally, we also recommend to use a machine-readable profile for the bags containing information about how the bag you are dealing with looks like. So how does such a bag look like? So what you see on the upper left side is basically the folder structure of such a bag. You see a couple of text files, the aforementioned DataSite XML file in a specified folder, metadata. And in the following slides, I will go through all the single files and explain what's in there. So on the upper right, you see the text file containing basic Bagot information, so which version is used, which character encoding is used, and that's basically it. In the next file, the bag info text file, this contains the date when the bag was created, contact information, and at the end also the profile which was used to create this bag. This profile you see in here is some kind of generic profile we defined in our working group. And the profile basically looks like this. It has some header information, like who has defined this profile, who is the contact, and so on, and which version it has. Then there are a couple of information about this Bagot info file, which elements are in there, which elements are required, and which are optional. So, for example, what you see, a contact email is required in the info file, whereas the source identifier or the contact phone number is not required. And finally, there are information about the content of the bag itself. So is there serialization of the bag allowed? So by default, a bag is a simple folder on a file system, and that's it. If serialization is allowed according to the profile, it can be also zipped or tarred or whatever, put into some package. Then there are information about the checksums which are supported and which files are required. You see here that the file metadata datasite XML is mandatory following this profile. In the datasite XML, well, there's datasite metadata. The source of this metadata is not defined, so one can imagine that if you have a repository with your own custom metadata model, that you pick pieces of this model and map them to the according datasite tags, and by this you can fill at least the mandatory elements following the datasite standard. But of course, as more information you put in there, the more it could be reused by the receiver of your bag in the destination repository. Finally, there are a couple of files related to the content. So the first one is the so-called fetch file. So Backit supports, on the one hand, to put the data in a specific data folder directly in the bag, or it allows to add a file called Fetchtxt, where you can refer to a file stored somewhere else. So what you have to do is, you see it in the line, you put the URL of the file, of the content, you put the size and the location where it is assumed to be in the bag. The next file, the manifest file, contains the checksum of the aforementioned data file. And finally, there's another tag manifest file containing the checksum for the datasite metadata document, which is contained in the bag. And that's basically how such a bag looks like. So one can imagine that it's comparably easy to adopt. It provides a packaging and exchange format between repository platforms. It can be done by the community. So this was one point we discussed a lot in the group. So the first idea was to suggest some kind of generic interface which can be implemented by platforms, but this can of course not be provided for legacy platforms. So the recommendation we have can be implemented outside the actual repository by a community, by arbitrary developer. The alignment to existing packaging solutions which already exists is rather easy. So just have to add the datasite metadata, and that's basically it. It supports both state-of-the-art and legacy platforms. It provides the users with a tool, for example, to transport or exchange or backup their content in an easy way. And it could serve as a basis for further agreements on content of these bags in order to improve the interpretability of the actual content. From the adoption point of view, we did a couple of prototype implementations during the lifetime of the working group. They exist for Fedora, for iCut, and for the Daria repository, and also for the KRT Data Manager, which is the repository platform we develop at Karlsruhe. Further adoptions came up during the last years. So the working group ended 2 years ago, and in this time adoption for Dataverse and the qualitative data repository came up and were presented at RDA plenaries. There is this generic profile which exists and which is available together with the prototypes and with the example pack on the GitHub page you see here as a link, and the final recommendations are available under the DOI you see at the end of the presentation. That's it. Thank you.
Thank you, Thomas, very much. Okay, over to our participants. If you have any questions for Thomas, please put them into the question box or raise your hand and we will unmute you. Nobody has any burning questions for Thomas? Okay, you can still put them into the box when we move on to our next speaker, because we will see these questions after the close of the webinar, and any questions can be answered offline as well. We can put you in touch with our speakers. Okay, so if we have
a few questions, Bridget.
Oh, I don't see any. Okay, Ryan.
Yeah, so I can call it if you can't see it. So we have
Yep.
this question here from I'll just expand it so I can actually read it. So we have first question from Nick Judy, who spoke earlier. I said, I don't know if you were aware of.
That was from Anne's presentation, I believe.
No, it's a new question.
Oh, okay, they haven't loaded for me yet. Then sorry. Go ahead, Ryan.
No problem. So Nick has asked, for Thomas, I don't know if you were aware of RO crate. If so, could you mention the relationship?
I am aware of it, and we were in contact with them, I think, and we discussed it. But at the time when our working group was in the final phase, this project was not that far, so we kept it in mind. But there was no time to take a closer look into it.
So we have a second question here, Thomas. So from Maggie Hellstrom. So who gains most here, the repositories or the data providers who upload content to repositories and then want this to be shared?
So sorry, I didn't get
who gains most here. So the data repositories or data providers who upload content
okay.
to repositories.
There was the or. Well, I hope the users at the end. So as the users can deal in a better way with the data they deposit somewhere, and they don't have to I don't know, to stick to a particular repository and to deal with keeping the data there for forever, so they can just easily pull the content out of the repository. But from both sides you mentioned, I think it's better for the repository providers, as they can, as I mentioned, the use case of the migration of data and move the data between instances. So this might help them most.
Okay. So with just another question from Ellie Berlin asking, are there any updates to these recommendations since 2018 that you can suggest?
Not really. So we were trying to get a follow-up working group, but this never happened. So, well, I think the recommendation as it is with the baguette as it is and the content is still valid. I know that there is an updated version of the baguette specification, the version 1, and for this, I think the recommendation or the solution we have is not fully compatible. This is what I know. So you should stick with the version 0.97. And up to now, we just had no time, no capacities to rework the recommendation into the direction of a new baguette specification.
Okay, and I think we have one more question. So from Joachim Philipson, he's asking, why did you settle on SHA 256 for checksums? Is MD5 not more easily obtainable from most repositories?
For sure it is, but well, there's a certain higher risk of collisions for MD5. So I think it was caused by a recommendation in the baguette specification. There's a recommendation to use SHA checksums.
Okay, thanks for that.
Okay,
Thomas.
thank you for that, Ryan. Thank you for managing those questions. And I think now we can move on to, thank you also, Thomas, I'm sorry, to our final speaker, to Dimitar.
Hello, everybody. Do you see my screen? Okay.
Yes, we can.
Yeah, I can see it.
So I'll start my presentation. I'm Dimitar Vassilev. I'm working with the Faculty of Mathematics and Informatics in Sofia University. So, and the subject of our presentation is what we understand under the development of a model for data integration, which is related to wheat and Fusarium resources. So why we, have chosen this subject? So there is a lot of information about Fusarium, and there is a lot of damages from Fusarium to the farmers and to the wheat production and to the cereal production, not only the wheat. So we decided to try to integrate all the information coming from different, databases, different other, external knowledge sources about Fusarium, and to try to complete it in a single, let me say, resource, in a single resource, which follows two major lines. The first line is to develop, to provide knowledge about the Fusarium itself, and the second is how to prevent all the damages. I mean, from the point of view of toxicology and of the Fusarium in the cereals and particular wheat production. So a few words about what we have taken as the initial material, data. So this is the data about the Fusarium mycotoxins and what they contain, how do they contaminate the grains, and how they make unusable the cereals, so the plants for food and feed. So after that, we study all the data resources for Fusarium fungi. What is challenging because of the complex taxonomic relations, and we define this in three major items. So the presence of species complexes whose representatives are difficult to distinguish using some morphological characteristics, the usual molecular approaches, and definitely the last thing is more interesting, is to define the chemotypes, or the type of toxins produced, which occurs during the within the species, or another problem, as they exhibit an additional, very sharp aggressiveness. So what is the there is a growing space of research and research which produce data, and not only research, but they remain, hugely fragmented. I mean, the all resources from where we integrate the data. This is the first place. This is all the data containing in the NCBI resources. So definitely with some additional extensions. So the annotated proteins in UniProt, the database collection in BioPsych, so, and the Fusarium MLST based by itself. So definitely there are a lot of additional sources of data, which lays behind this screen. Definitely the most important data was the very important data we come from the wheat information IS. And finally, our task was how to integrate all this stuff, and using the the metaphor from the well-known pictures, how to one ring can rule all this data. So our concept lays on let me say two levels, two sides of the solving the problem. The first concept is to develop one platform for all external sources related to Fusarium. After that, to develop the application interface. So we use the RESTful APIs for each existing platform, and RESTful standards can be integrated in our scenario. So we developed a platform which is fully distributed and based on the modern solutions and environments as Kubernetes, Docker, and all cloud providers supported images. So, and after that, we, how to say, look at the lower level, so how to use the external knowledge sources mentioned in the few slides above. This is the sources from mostly for molecular side of the Fusarium and the wheat and their interactions and relations. This is sources from NCBI, European Bioinformatics Institute, big database as Uniprot. Why you use these, how to say, these sources in the first place? Because they have all very well developed APIs, so interfaces. But anyway, in the bottom of the third level over there, we used a lot of different sources, for which we built a, how to say, a joint interface, how to use them. So, and the second level of our users, this is the screen what our system information system shows. So this is the user's interface, let me say, and this is how to complete search is based on all the external sources. This is the first line below the green and red button, and we provide links for all reference-related databases listed there, and we developed separate modules for each child and sibling related Fusarium data. This is, I mean, how to say, I'm speaking in the context of the hierarchy of our information system. And we have a separate module for Fusarium with links for all database where we found it and all relations where we found it. And we support a huge amount of data via the asynchronous request and visualization, I mean, in terms of pagination. So the things we are finishing to work on, this is how to include the toxicology side of the project, the data, I mean, the mycotoxin information noted in this slide. So what have we as an information about the compounds, biosynthetic pathways, proteins, and also they'll how to say, we're retrieving them mostly from NCBI and MetaPsych. So additional information, this is what we are working now about the geographical distribution of strains producing particular toxin. It will be, how to say, retrieved and used from the European Fusarium database called LuxMSCC. So after all this stuff, what we've done, I would say that maybe our intention to develop a findable, accessible, interoperable, and reusable semantic model of platform for integrated data from different sources, concerning representatives of genus Fusarium and their interaction with the wheat. And so our platform, how to say, aims to contribute the discovery and presenting of new knowledge concerning the role and importance of Fusarium and in cereals, and in particular in the wheat. So thank you very much. This was my presentation.
Thank you very much, Dimitar. Once again, over to the audience. If you have any questions you would like to put to Dimitar, either raise your hand or write them into the question box. Okay, we have one question coming from Catherine Rousset, and her question is, where can we find the semantic model?
Yes, I can send her by mail. Sorry, I didn't put in the presentation. I missed it up too. I can send Catherine the GitHub link to use all the software we have developed and we're developing. So
okay, so I can put you in touch with Catherine offline, Dimitar, after the webinar.
Yeah.
Do we have any more questions coming through? I don't see anybody's hand up. Okay, we have a question here from Ellie Berlin. And her question is, she would like to know, is it a lot of work to integrate data from each different resource or does your process make this easy?
So let me say in percentage of the whole work, the development of the platform takes about, let me say, 40%, and the 60% is how to find, how to search, and how to integrate the data. What data should be integrated? This is the, how to say, answer to. I can put like an answer. So.
Okay, thank you, Dimitar. And Catherine is back with a question. Do the alignment between the semantic model and database, is that difficult, the alignment between the semantic model and database?
Okay, some of the approach, the technology of the approach stayed hidden, how to say, of the vision here in the slide. We apply several models for data integration. The conception of our models is to use two-stage data integration. One is horizontal data integration. Horizontal data integration could be made from the different data sources of different databases on the background of using a non-relational database like a MongoDB. So to integrate all the text necessary for the project. So, and after that, how the second level is organized to manage this first level of data integration. It is developed on the basis of GraphDB, Neo4j, and it's the reason here is to make all the links, the relations between the attributes of the first level database. So using the approaches, well-known approaches, linked data, how to say this data is definitely semi-structured, and so this is the conception of our data integration. Two levels. This is a horizontal and vertical data integration.
Okay, thank you. Okay, one final comment. It's not a question, from Wendy Wong, but she would like to get in touch with you, Dimitar. So I will put you both in touch with each other. She's interested in the GitHub on semantic platform.
Yes, with pleasure.
Okay, I'll put you in touch. Okay.
Email or any. Okay. Well,
yes, I'll do that. Yeah. Okay, I think that's it with the questions. Thank you very much, Dimitar, and thank you everybody for your questions. Ryan, if you could switch back. Sorry, Dimitar, please.
Yes, yeah, a few words. Our project is a quite new project, so the project of the other colleagues out there, not how to say, not very new project, but we started to work less than a year ago. This is a new idea, so maybe not everything is how to say within the most, how to say, desirable details and everything, but for us it was majorly the conception. So the conception is made that there is no, how to say, a good data integration platform for how to use the Fusarium data and the interactions of Fusarium with serial. So, and after that to develop all the computational side of this idea. So this I wanted to say. Sorry.
Okay, that's fine. Great. Thank you very much, Dimitar.
Thank you.
Okay, Ryan, if you could switch back to my screen, please, and I'll just finish off with 2 or 3 announcements for everybody.
Do you have access to your screen now, Bridget?
Should be. Can you see my screen?
No, I can't.
Yeah, I can.
I'm afraid I've frozen again. I have that same issue back, so I can't change anything.
Okay, what I will do is I will put the final few slides from
if you've got if you could put the slide 6 up, Ryan, yeah, that would be great. The catalogue, and I'll run through those.
2 seconds here now. I will open that up.
Thank you.
And yes, so that is slide 6. No problem. I will just share my screen. Bear with me, everybody.
Yeah, I think we've got 2 or 3 minutes left of everybody's time. If you can just bear with us.
Yeah, it doesn't matter. Okay. Okay.
Okay. Are you viewing Ryan's? Can you see Ryan's screen now?
Not at all. Sorry, I see only the RDA. How to say? background.
Yeah, it's just waiting to come up.
Yeah, apologies, no, it's not letting me share my screen.
As technology failed us right at the end.
Yeah.
Better at the end than at the beginning.
Yeah, I'm afraid not. It's just I think I'm having the same issue as
Okay,
you
all
had.
right. I'll just quickly go over. I just wanted to tell our audience about the recommendations and outputs catalog, where they're all gathered. All the RDA recommendations supporting outputs or other outputs, they're all gathered into one catalog, and you can find this on our website, and you can search for them according to their status, their data lifecycle topic, or their scientific domain. You will be able to see this in the slides as well once we upload these to the website. And the last one was just to tell you about your adoption story. Ask if you're an adopter, because RDA is actively seeking new adoption stories so that we can inspire further uptake of RDA outputs. So if that's you, then please submit your story, and the link again can be found on the website, but this will come through in an email to you as well. One more announcement here. A project which has been supported by the RDA Europe 4 is the publication of a maximum of 30 articles in the CODATA Data Science Journal Special Collection on RDA, and there are still funds available which pay for your article processing charges. And the call has been extended until the 17th of July. So if that's you, if you're interested, then please hurry, because it's a first come, first served basis. And this call is open for everyone. It's not just restricted to Europe. Okay, so I'm going to close the webinar. I would really like to thank our three presenters, Anne, Thomas and Dimitar, for presenting today. And thank you, the audience, for listening, for coming and for putting your questions to the speakers. Those that were unanswered will be forwarded to our speakers offline, and any comments that were made, I will pass them on as well. Please remember the link to the recording will be posted in the next few days, and if you need to get in touch with us or ask any other questions, please email us at inquiries@rdaalliance.org. Thank you very much, everybody.
Thank you.
I wish you.
Thank you, Bridget.
Thank you very much. Bye-bye. Bye-bye, everybody.
Bye.
I'll leave you to close the webinar, Ryan, because I'm frozen here.
Yeah, no problem. Thank you once again. Thanks to our presenters and thanks to all for attending.
Thank you, Ryan.
Thank you, everybody. Thank you.
Thank you for the questions.